One final thing I want to touch on with electron configurations, just to make sure, because I don't think I've brought this up at any other point, is thinking about the electron configurations of what we call excited states. What is an excited state? So everything we've been talking about up to this point is what we call the ground state of an atom or an ion. And the ground state means the lowest energy configuration. But that's not the only possible configuration for an element. Let's consider a pretty simple one. Let's look at sodium again. So sodium has again, we'll go back to the periodic table to make sure I don't mix this up. Sodium has the neon core, right? Go to the row before sodium, and then an electron in the 3s orbital. So its configuration is the neon core and one electron in a 3s orbital. And that's the lowest possible energy state it can be. But what we can do is if we somehow put in energy, this is often, a couple ways this can be done is through light. Another way is through electricity. You can actually get this electron to move to a different orbital. So, and we often write this with like a star to indicate that it's not regular sodium, but it's also not an ion. It hasn't lost the electron's just moved up to a higher energy level. The electron configuration here we would put it into the next available orbital, and we would say neon 3p1. This is not just a regular sodium atom. This is now an excited state sodium atom. So this would be the first excited state, meaning it just goes up to the next possible orbital. Another possible excited state would be you could put a different type of excited sodium atom would be maybe it goes all the way up to a 4s orbital. Right? This is another possible excited state. The key point of excited states is just that at least one of the electrons has moved to a new orbital. It's not in the lowest possible energy orbital. So I just want to mention that there may be a few questions related to excited states and things like that. Just so you know what we're talking about if we mention excited states. So just we were looking here just at one electron, but maybe you have something like, if we go to the next element over, magnesium. If we think about magnesium, it's also going to have a neon core, and now it has 2 electrons in the 3s orbital. And what an excited state for magnesium would probably look like is one of those electrons. So again, an excited state, one of those electrons would stay behind in the 3s orbital, and one would maybe go up to the 3p orbital. This is an example of what the first excited state for magnesium might look like. So it doesn't have to be all the electrons that move. And without knowing more information, you wouldn't necessarily know which orbital it goes to for sure. But when we're talking about excited states, this is different than an ion where the electron leaves. It's not part of the atom anymore. This is just the electron has moved to different orbitals that are higher energy than its ground state, where everything's at the lowest energy.